3. Io-Atlas looks like a comet, but it moves with the precision of a machine. If it's natural, it's breaking every rule. So what is this thing? And why is it defying everything we know about comets? Let's start where this mystery began. In the remote desert of Namibia, a team of astrophotographers pointed their cameras toward one of the darkest skies on Earth. It was during a lunar eclipse when the moon vanished into the shadow of our planet, leaving the night untouched by any reflected light. They could have captured any star or galaxy. Instead, they chose something different, an object labeled 3I, or Atlas. What they saw stunned them. The object glowed bright green in the dark sky. That doesn't make sense. 3I or Atlas shouldn't glow green, at least not according to the rules of chemistry and physics we understand. Most comets turn green when carbon molecules in their halo react to sunlight. But here's the twist. 3I or Atlas doesn't have those carbon chains. Scientists checked. They scanned the light coming from the object and found almost no diatomic carbon, yet it still shines a vivid green. So, what's lighting it up? Maybe it's the composition, or maybe something else entirely. Astronomers have spent months watching 3I or Atlas through some of the best telescopes on Earth. They noticed it's filled with carbon dioxide instead of the usual water vapor. That alone is strange. Normal comets have far more water than CO2, but Atlas is the opposite. And buried in that cloud of gas and dust, scientists also found metal, specifically nickel. Now, nickel isn't rare in space, but it only vaporizes near the sun when temperatures soar high enough to melt metal. Atlas isn't anywhere close to that heat. When the nickel was detected, the object was floating between Mars and Jupiter, way too cold for vaporized metal. So how do you get nickel gas out there? Some theories stretch into wild territory. Rocket engines, for example, use nickel-heavy alloys. Burn those, and you'd see nickel and carbon dioxide in the exhaust. Of course, nobody's saying it's an alien ship, but if you wanted to design one, that chemical fingerprint would fit. Still, even if we set that idea aside, Atlas refuses to behave like any normal comet. Here's why. Most comets wobble, twist, and speed up or slow down as they melt under sunlight. When ice turns to gas, it acts like a tiny thruster, pushing the comet in random directions. Scientists call that non-gravitational acceleration. Atlas doesn't do that. Its movement is smooth and steady. Over months of observation, it barely shifted course. To compare, 2I Borisov, another interstellar comet, drifted over 100 kilometers a day. Hale-Bopp, one of the biggest ever, moved about 10 kilometers daily. Oumuamua, the most famous interstellar visitor, zigzagged by more than 1,000 kilometers per day. Atlas? Just 1.5. That's steady enough to seem deliberate, as if something or someone keeps it on track. Of course, nature surprises us all the time. Maybe it's just bigger, heavier, or built differently, but that kind of consistency still makes scientists uneasy. You don't expect precision like that from ice and dust. You expect it from machines. Now here's where it gets really interesting. When astronomers traced Atlas's path backward, they found that it came from the same direction as the famous WOW signal. The WOW signal was a mysterious radio burst detected in 1977 by researchers at Ohio State University. It lasted 72 seconds, came from deep space, and matched the exact frequency of hydrogen, the most common element in the universe. If anyone wanted to send a message meant to be recognized by another civilization, that's the frequency they'd choose. No one has ever heard another signal like it. For decades, it stood alone. And now, an object glowing green, moving steady and coming from that same region of space, appears in our skies. Coincidence? Maybe, but it's the kind of coincidence that makes you look twice. Some scientists argue that Atlas is linked to Sagittarius, where the WOW signal originated, is just a spatial overlap. The galaxy is vast, after all, but others find it strange that the timeline almost fits. In 1977, when that signal hit our detectors, 3I or Atlas would have been near the outer edge of our solar system, past Pluto. If the two are connected, it means the signal could have been a kind of hello from an approaching visitor. Still, we have to stay grounded. There's no proof of alien intent here, just patterns and puzzles. But those puzzles tell us something bigger about our own curiosity. Every time we find something like Atlas, we're reminded how little we really know about what moves out there. Let's pull back for a moment. The steady movement, the missing carbon, the metal vapor, the chemical oddities, all point to one conclusion. 3. Our Atlas doesn't play by our rules. But instead of jumping to wild conclusions, scientists are gathering every bit of data they can. They're tracking how its tail forms, how its light shifts, and how it interacts with solar radiation. If it keeps glowing green while it nears the sun, that will challenge a lot of what we think we understand about interstellar material. Atlas will soon swing around the sun, and when it does, Earth will be on the opposite side. That means we might not see it again for a while. But if by some chance it slows down or changes path, it could reappear closer than expected. And if that happens, the debate will reignite in full, because a steady, glowing object from beyond the stars isn't something you can ignore. Now, picture what it means for us to even detect something like this. A rock from another star system, carrying different chemistry, different physics, maybe even a different history of creation. It challenges the idea that our solar system is a closed bubble. It proves we're part of a wider exchange, where matter drifts across light years, sometimes ending up right at our doorstep. Think about it. Each interstellar visitor we've seen has changed how we view our cosmic neighborhood. Oumuamua looked like a flat cigar-shaped object, maybe a fragment of something artificial, maybe not. 2. Borisov acted more like a comet, but still carried elements never seen before. And now 3. Atlas, the strangest of them all, appears to blend features from both. If we ever find out how it formed, it could reveal what the space between stars is really made of. This is also a reminder that space exploration isn't only about rockets and astronauts. Most of the major discoveries happen with quiet patience. A telescope pointed at a patch of sky for hours. A computer crunching data for days. A scientist notices a color that shouldn't exist. Those moments move science forward more than any grand launch. The mystery of 3i or Atlas also connects us emotionally. There's something poetic about the thought of a green light crossing our system after billions of years of drifting. It has no voice, but it sparks endless questions. Why green? Why steady? Why here now? Maybe the answer is simple chemistry, or maybe it's a reminder that the universe still holds secrets that even our most advanced machines can't decode. When you look at the night sky, remember that among those distant stars, there are travelers. Silent, slow, and ancient. They cross space not because of purpose, but because of physics. Yet when one of them acts like it might have a purpose, our minds can't help but wonder. Scientists are preparing for the next observation window. When Atlas becomes visible again, they'll measure how its light changes, check for any radio emissions, and compare its pattern with other known objects. If the data shows more chemical imbalance or unexplained heat, that will keep the mystery alive for years. Until then, Atlas drifts on. It doesn't speak, but in its silence, it tells us that discovery often begins with confusion. We look up, see something that shouldn't exist, and our entire understanding expands a little more. It's easy to forget how vast space really is until something like Atlas forces perspective. The distances between stars are so great that even light, the fastest thing in the universe, takes years to cross them. Yet here we are, tracking a single glowing object that somehow made that journey. It reminds us that movement across the cosmos isn't rare, it's just hard to notice. Most of these wanderers go unseen. Atlas is the lucky one we caught. The story also pushes us to imagine what else might be traveling through the void. Dust, rock, ice, maybe even debris from civilizations long gone. Every passing object could carry clues about the conditions that shaped other systems. Each is a message, not written in language, but in chemistry and motion. We're just learning how to read it. If Atlas truly came from another star, it might hold the fingerprints of that system's birth. Studying it could show how materials vary between stars, how planets form differently, or even why some systems produce the right mix for life. Every molecule could hold a story older than our sun. Someday, a future mission might catch up to an object like Atlas. It could take samples, scan its surface, and decode the truth. Until then, we're left with questions and data points, and sometimes that's enough. Because curiosity is what keeps us exploring. If you want more stories about strange visitors passing through our solar system, subscribe and stay curious.